4.1, review and preview. So we're going to remind you what a function is. Remember, a function is a sort of relation that for every input there's only one output. Another way of saying it, it maps each element of the domain to one element of the range. So I'm going to write down a simple function here. Let's say our input values, so the domain is -3, 0, 4, and 5. And the function, you know, there's this function that does something to each one of these input values. The function gives an output value. When you put -3 into the function, you get an output value of -1. When you put 0 into the function, your output is 2. When you put 4 into the function, the output is 6. And when you put 5 into the function, the output is 7. Now, are you able to see what the function is? What's the rule? What's the function doing to all these input values? The function's taking all those input values and it's adding 2. It's increasing it by 2. So if this is our domain, our x values here, and this is our y values here, let's write an equation for this function. It would be y equals, what's it doing? It's taking the input value, which is x, and it's adding 2 to it. So there you go, there's your equation for that function. Now what we're going to introduce you to is the inverse of a function. We've never talked about this before, but it's actually a pretty simple concept. What the inverse of a function does is it undoes what a function does. So if this function adds 2, guess what the inverse function does? It subtracts 2. So another way you can look at this is, as it says here, it undoes what the function does. So if you started with -1, what would the inverse function do? It would get you back to where you started. It would get you back to -3. If you started with 2, it would get you back to 0. If you started with 6, it would get you back to 4. If you started with 7, it would get you back to 5. Okay? It doesn't mean I just moved the range over here in the domain. This is like, I'm talking about if this was the domain and you put it into the inverse, it would give you these ones as the range. So what's the equation this time? Well, basically what you're doing to get these y values here from these x values here, you're taking the x values and you are subtracting 2. That's exactly what we said, right? If this one's adding 2 and we want to do the inverse, we want to do the thing that undoes that, then you would have to be subtracting 2. So hopefully that all makes sense so far. So now what we're going to do is we're going to plot these, because you know, you can think of this, you could draw it with this mapping diagram here, but you'll remember from back in grade 10 or something, we also said another way you could write this is -3, -1, and 0, 2, and 4, 6, and 5, 7. And same here, this is -1, -3, and this is 2, 0, and this is 6, 4, and this is 7, 5. So we're going to graph both of these. First of all, we'll graph this one here. So -3, -1 is the first point. -3, -1. The next point is 0, 2. And then we have 4, 6. It's a bit annoying having to go back and forth like this. And finally we have 5, 7. So 5, 7 is right there. And I tell you what, let's pretend that this is only part of the domain. Let's say the domain's all real numbers, like you could put anything into here. So if you were to graph it, then it wouldn't just be 4 points, it would be a whole line. Let's draw the line. We'll do that now. There we go. So that's the function. Right there, that's the function. Now what we're going to do is, in a different color, I should have done this all red here, I'll do the inverse function. So we have -1, -3, which is right here, 2, 0, 6, 4, and 7, 5. And I'll draw a red line to join all those points together. So this is the inverse function right here. Now this probably isn't the best example, to tell you the truth, but if you wanted to draw a line that acts as a mirror to reflect the function onto the inverse function, where would the line go that would reflect those? Well, we should notice that these two lines are parallel, so the reflection line would be right in the middle, wouldn't it? So I'll draw that with a dotted line, and I'll make it purple. So there you go. Now there's a few things you need to notice here. One thing is, if you can compare, so we've got the function and the inverse function. If you compare the domain here and the range here of the function, how do they compare to the domain of the inverse and the range of the inverse? Well, they're just opposite, right? The domain here is the range there, the range here is the domain there. Great. If you look at the points, what do you notice about the points? Well, each point's just turned around. -3, -1, now it's -1, -3. So if I told you there's a point on this equation, this function right here, and let's say one of the points that's on it, because it's true, there really is a point here, let's say one of the ordered pairs that works in this function right here is 99 and 101. Quick, if that's the truth, what is one of the points that must work in this one? 101, 99. You just have to switch the order. Okay, so there's two things we've noticed. A third thing we've noticed is once you've drawn the two, there's a reflection line that's right in between them. And we're going to talk more about that on the other side, but you're going to see it's always in the same place. It's always going to be this exact line right here. What's the equation of that line, by the way? The equation of that line is y equals x. It's the mother function of all lines, the most basic line right there, y equals x. And the fourth thing we want to talk about is how to start with the equation of a function and how to go to the inverse of a function. So basically, here's how you do it. And I'm going to write this down for you on the next page. What you do is you start with the function right here. You just switch the x and the y. Where I see y, I put x. Where I see x, I put y. There you go. That's the inverse function right there. But what we want to do is we want to isolate the y. We want to get the y by itself. So to get the y by itself, the problem we have here is this +2. So what we're going to do is we're going to move that 2 to the other side, and it becomes minus. Or if you want, -2 and -2 on both sides. So you end up with y equals x minus 2. That should be the inverse function right there. And if you look, it is. That is the inverse function. Okay, so those are the four things we need to know. Here we go. We'll write them down for you. Number 1, the ordered pairs in a function are reversed in the inverse. So I already talked about that. If there's a function and I told you that one of the points in the function is -4, 2.5. This is in the function. So give me a point that must be in the inverse function. 2.5, -4. Okay? Next thing. To find the inverse of a function from its equation, so again, if we had an equation, so why don't we do an example again? Let's say we had the equation y equals 2x minus 1. That's the function. And I wanted to know what the equation is of the inverse. There's two steps. I already just talked about this. You're going to interchange the x and the y. So where I see y, I'm going to put x. Where I see x, I'm going to put y. And then the second step is solve for y. So in order to get this y by itself, the first thing I need to do is move that -1 over, or add 1 to both sides. So you get x plus 1 equals 2y. I want to get the y by itself. This is 2 times y, so I'll divide by 2. And the way I like to do this is divide everything by 2 like this. So what I end up with is these 2's cross out and I just get y equals x over 2, or if you want, 1/2 x, it's the same thing, plus 1/2. This is your inverse function. This is the function. This is your inverse. Actually, I should get out of the habit of saying inverse function. I should just say inverse of the function, because not every inverse is a function. Anyway, we don't need to talk about that today. To find the inverse of a function from its graph. So remember, once you've graphed something, if you want to get the inverse, what you can do is flip it or reflect it over the y equals x line. And finally, the domain of the inverse is the range of the function, and the range of the inverse is the domain of the function. Those are all the things that we need to be aware of when it comes to inverses. So let's do one other question here. We're going to graph this function right here, y equals the square root of x minus 2. And we're also going to graph the inverse on the same grid. And then we're going to figure out what's the equation of the inverse. So let's start by graphing this. I don't think we've ever graphed in foundations, we've never graphed square root functions, so let's make a little table to help us out. And let's think of this. What kind of numbers do you want to have in the square root sign? We'd like to have perfect squares, because we know what the square root of perfect squares. So we'd like the inside of this square root to equal like 0 or 1 or 4 or 9 or 16, right? All these perfect squares. We can't have this middle bit be negative. Like if you put 0 in for x, if you decide to put 0 here, it's not going to work. 0 take away 2 is -2, and the square root of -2 you can't do. So don't put 0 in there. What's the smallest number you can put in here so that you could actually take the square root? The smallest number you could put in there is 2, because if you put 2 in there, 2 take away 2 is 0. So if I put 2 in, I get 2 take away 2 is 0, and the square root of 0 is 0. Great. Next thing I want to do is I want to make it so it equals 1 in here. What should I put in for x? Let's put 3 into the x. 3 take away 2 is 1, and the square root of 1 is 1. Nice. Now I want this inside part to equal 4, so what should I put in for x? 6. If I put 6 in there, 6 minus 2 is 4, and the square root of 4 is 2. If I want this inside part to equal 9, what do I have to put into x? I put 11 in there. 11 minus 2 is 9, and the square root of 9 is 3. We won't be able to fit 16. We'd have to put 18. It's too big. So these are the ones we're going to graph. 2, 0, 3, 1, 6, 2, 11. Well, it's off the grid a little bit, but I'll put it right there. Okay, this is what square root functions look like. They have this shape like that, and it goes on forever. Okay, that's the function right here. Now, to draw the inverse function, there's a couple ways we could do it. One way is you could draw that dot, well, it doesn't have to be dotted, but the reflection line, the y equals x line, like this, and then you could just reflect this curve here over the line. There's just one problem. Your math teacher can't do that. I don't know why. I just have a real hard time doing. I guess it's going to look something like this, right? Something like that. So that's one way you could do it. The other way you could do it, which I think is probably a better idea, at least for me, is to take all these points. Since we graph 2, 0, what's one of the points going to be in the inverse? 0, 2. So right there. We graph 3, 1 in the inverse, it's going to be 1, 3. We graph 6, 2 in the inverse, it's going to be 2, 6. And we graphed 11, 3 in the inverse, it's going to be 3, 11. And hopefully it's going to look like a reflection over this dotted line, and I would say yes, it does. So this is the inverse right here. Great. Now the last thing we want to do is we want to figure out what the equation is equal to. So if originally it was y equals the square root of x minus 2, remember how we do this? Wherever we see y, we put x. Wherever we see x, we put y. And now we have to solve for y. Okay, a little tricky here. First of all, we have this square root sign here. So what are we going to have to do to get rid of that square root? We're going to have to square both sides. When you square both sides, you get x squared on that side. And on this side, you get, you know what you get? If you take the square root of something and square it, they just cancel out those two operations. So you're just left with y minus 2. Now to get y by itself, because that's what you're trying to do, all you have to do is take the negative 2 and put it to the other side. And you'll get y equals x squared plus 2. This is your inverse. Now, if some of you are really thinking here, you might say, well, wait a minute, I know that sort of function here, this sort of equation. That looks like when we were working on last year when we were doing parabolas, right? X squared plus 2, there's a vertex of 0, 2, here's the vertex, and it should be a parabola. This is just one side of the parabola. What's going on here? Well, the reason for that, this is getting a little bit advanced, the reason for this is because when you take the square root of something, just by convention, we only take the positive answers. So we only have kind of 1/2 of the answers here. Remember, if I asked you, for example, what is a number that would solve this equation? X squared equals 4. What is a number that solves that equation? Well, 2 solves that equation, but so does negative 2. So the reason that you kind of only get half a parabola is because by convention we only take the plus when we take the square root. But if we were to include the plus and the minus, then you would get the whole parabola. Anyway, I don't want to stress out about that. That's more a pre-calculus 12 topic, and I don't think it's going to be of importance to us. If you want me to explain that more, I'm happy to do so. Okay, the last thing we're going to do is we're going to find the inverse of this one. So, same deal. We're going to replace the y with an x. We're going to replace the x with the y, and we're going to get the y by itself. So let's deal with this plus 6 first. Subtract 6 from both sides, or move the plus 6 over, you get x minus 6 equals 2 over 5y. Let's deal with this 5 first. This is divided by 5. So what I want to do is I want to multiply this side by 5 and multiply this side by 5. 5's cancel over here. And let's do mountains there. So you end up with 5x minus 30 equals, what is that, 2y? And since that's 2 times y, what I'll do is divide by 2, divide by 2, divide by 2. So I'm left with just a y equals 5 over 2x minus 30 over 2, and 30 over 2 is 15. There you go, that's the inverse. So if you put any number into here, let's say put the number 15 in here. Let's see what the output number is. So my input's 15, I put into x. 2 times 15 is 30, divided by 5 is 6, plus another 6 is 12. Okay? What this equation tells us is, if we put 12 into this equation, we should end up back at 15. So let's try. If I put 12 into this equation, 5 times 12 is 60, divided by 2 is 30, and then take away 15, you get 15. So you see that this red boxed equation undoes whatever this highlighted equation does up there. That's the idea of function and inverse. Okay, we are now ready to proceed with Chapter 4.